Have you ever wondered how hard it is to actually learn coding? Or maybe you've seen a horrible batch of code and you've thought, who the hell wrote this? I wanted to answer both of those questions by attempting to build a working chess game with zero coding experience. I'm not a computer science major, I'm not even in STEM. I just wanted to know if an average person could successfully build something as simple as chess. Here's how it went. To even have a chance of pulling this off, I had to solve a series of problems that got harder and harder as I went. Some of them way harder than I initially expected. I'm looking at you, King Chex. I was walking into this challenge with nearly zero preparation. All I had to show for myself was a completion certificate from a 1-hour Python quick start guide on LinkedIn Learning. I also set one rule for myself during this challenge: no AI. So when I started working on rendering a chessboard, the reality of how difficult this was really going to be quickly set in. A quick Google search led me to a Python package called Turtle, which is a library that allows you to create shapes on a canvas and move them around with your code. Apparently, this is mostly used to teach kids about the basics of programming, so I thought it was well suited for my intelligence level. Using the Turtle package, I tried out a few different methods for rendering my chessboard with varying levels of success. I thought I had it solved at one point when I came up with a way to make a square trace the path of the chessboard and leave a stamp of itself for each square, all while alternating colors. But I ended up having to scrap that solution. Instead of stamping a shape, I needed to make a separate shape for each square on the board and send them to a specific coordinate. This worked much better because having actual shapes allowed me to detect when a square was clicked by the user. To pull this off, I created a dictionary that contained hard-coded coordinates for each square to navigate to. If you've coded before, you probably are already typing down in the comments about how dumb this solution is. Yeah, I know, but don't worry, there's even more dumb ideas coming soon, so just wait and see. With my hard-coded dictionary and my squares all in their forever homes, I got started on making some chess pieces. Each piece had unique challenges to solve, and I was really hoping that the pawn would be simple. It was not. The pawn looks like a simple piece until you realize that it actually has 6 rules that it must follow. Oh, the pawn just moves forward. Well, that is, unless it's the pawn's first move, then it can move 2, but only on that move. And if it's capturing, then it moves diagonally. And it can capture with a special rule called en passant, which I didn't even end up trying to touch until much later. So my first goal was simple. I needed to spawn in a piece on this board and move it to the square that I click on. Easier said than done. After some trial and error and lots of quality time with the Turtle Library Wikipedia page, I was finally able to get the pieces to move around by clicking. To continue testing, I put multiple pieces on my board and realized that I have a problem. There was nothing preventing the pieces from occupying the same square. My solution? You got it. Another hard-coded dictionary. This one kept track of which pieces was on which square. Next, I made movement restrictions for the pawn that only allowed it to move 2 squares forward on move 1 and 1 square forward on any other move. Look at that, the pawn's working. Next up was the knight. The nice thing about the knight is that it can hop over pieces, meaning I didn't have to figure out if anything was blocking it. The knight essentially has 8 squares that it can move to, so I came up with an elegant solution. Using the coordinates from my notation dictionary, I wrote 8 if statements that check if the coordinates of the selected square match up with one of these 8 squares. Genius? I know. Then came the bishop. And this is the point in the project where the difficulty really started to step up. Solving the basic movement wasn't too bad. I just ended up comparing the distance traveled along the x coordinate and the distance traveled along the y coordinate. And if these 2 distances match, then the bishop is allowed to move there. But here's what was tricky about the bishop. The bishop is the first piece I've made that can't move through other pieces. I ended up using some very sophisticated mathematics to determine how far the bishop was traveling and what direction it was moving. Once I had that information, I was able to check all of the squares between the bishop and its destination square to determine if anything was blocking its path. Explaining it after the fact might make it sound simple, but as someone who has never coded in his life, this felt like a huge accomplishment to figure out. The rook and the queen were actually very similar to the bishop. The rook followed the exact same concept, just horizontal and vertical. And the queen, get this, I had a beautiful thought. What if the queen is just bishop plus rook? And yes, it was. I literally just copied the rook logic, pasted it directly after the bishop logic, and wrapped that all in a nice little if piece equals queen, and boom, the queen was working perfectly. The king was also really easy, at least at first. I just created some conditional logic that allowed the king to move to any immediate surrounding square that wasn't occupied. Little did I know that the special rules for the king would later prove to be the most challenging aspect of this entire project. But here we are. At this point, the game is starting to really resemble chess. My vision for this project was to create a pass and play chess game that allowed two players to face off locally. So the next thing I wanted to build was a board flipping system. I needed a way to flip my board upside down so the other player could see the position from the correct orientation. My solution was simple. I was simply going to multiply all the coordinates in my notation dictionary by -1 after every move, and then send all the shapes to their new positions. Was this an elegant solution? No. But did it work? Also no. At least not at first. However, after addressing a couple of bugs, the board flips were working. At this point, I had to build out a system that keeps track of which team is taking their turn to prevent the black pieces from being moved on a white turn, and vice versa. Next up was capturing. For most pieces, I could reuse their normal movement logic and simply allow them to select squares occupied by enemy pieces. The pawn, however, needed some new rules. By adding an extra if statement into the pawn's movement logic, it could now move diagonally, but only when that move resulted in capturing an enemy piece. Also, just for anyone wondering, never Google how to remove turtle. The results are scary. But hey, look at this. This game is really starting to look like chess. I felt so close, but I would soon realize that I was still so far. If you aren't aware, chess has a few special rules that allow pieces to do things they normally cannot. The first is called castling. If both the king and the rook haven't moved, the player can make them do a little flip-flop. I added 2 legal squares for the king that were only allowed if both the king and the rook had yet to move and they were not blocked. Then I added a special function that gets called if the user selects one of these squares. This function forces the rook to also move to its correct square. The second special rule is called en passant, which offers some new tricky problems. If a pawn moves 2 squares forward on its first move and an enemy pawn is sitting directly beside it, that enemy pawn is allowed to capture it as if it had only moved 1 square. To make this work, I added another new dictionary, but this time it wasn't hard-coded. I know, he's learning. When a pawn makes its initial 2 square move, I temporarily mark the square behind it as en passant eligible for 1 turn only. If an opposing pawn selects that square on its next move, the game treats it as a valid capture and removes the pawn that moved 2 squares. If the capture doesn't happen immediately, then that opportunity disappears. So at this point, I was 90% of the way there. All I had to do was figure out how to prevent the little old king from moving to illegal squares when it was in check. You see, actual chess games online, they won't even let you make that mistake. If the king is in check and you try to move him to a square that's still attacked, the game will just go, nope. You don't get to oops your way into losing in chess. It won't even allow you to make an illegal move in the first place. And I really thought this was gonna be one more little solve. It wasn't. I had to rework my whole movement system to get this working. You see, up until this point, I was checking if a piece was allowed to move to a square after the user selected it. Like, click a piece, click a square, and then run a bunch of logic that decides if that move is valid. That works fine until you introduce the king, because now it's not enough to just ask, can the king move to this square? You also have to ask, is that square attacked? And that's not simple. So instead of waiting for the user to click a square and then checking if it's legal, I made the game constantly store all the legal moves for every piece and recalculate those moves after every move. So I used loops within loops to check every legal square for every single piece. So once I had that, I could finally do the king check the right way. When it's the king's turn, every possible king move gets filtered through 1 extra rule. If that square exists in the enemy team's legal moves dictionary, then it's illegal. And that meant that the king can't walk into check. The king can't stay in check, and the game won't let you make a move that leaves your king exposed. And when I finally got that working, I could finally say it. I made a chess game. Thank you for watching. Goodbye.